but you need to recognize this is one of either the sine or the cosine, and you can use either one. Okay, but if I set this up to see, the first thing I'm going to do is I'm going to look, here's my minimum value, my maximum value. So what's that total distance between the min and the max here? 12. Okay, so that means if I cut that in half, that's going to be my amplitude. So half of 12 is 6. So I know that I'm dealing with, it asked me to use f of x. So I have f of x is equal to, it could be a positive, could be a negative. So I left some room in case I put a negative here. And I'm going to choose 6. Now, if I look at where my midline is, my midline is 6 units from the ends, the max and the min. So I know my midline is going to be right here. If my midline crosses through points that are easy to recognize, okay, then I can use sine. If my midline doesn't cross through points on the graph where I can easily see what the intersection is or what the coordinate is, then I might want to use my max and min. And if that's the case, I use the cosine graph. But the fact that this right here, I can see this point right here, I'm going to go ahead and use sine. Like I said, it doesn't have to be sine. I could use cosine, but I'm establishing sine as the function I'm choosing. Okay, and so when I look at these, what I can wind up doing, what I can do in this particular case is I know I'm going to have a sine of some quantity, and then either plus or minus. So I see my shift is this midline. The midline is the equation y equals -5. And so I know that -5 is what's going to go outside my function. So I take care of that shift. So all I need to do is take into consideration the period and the phase shift. So let's look at the period first. Okay, so when I look at the period, what I can do is I can identify that one full rotation of my sine graph here, one full phase, goes from this -5 all the way to 7. So what is that total distance there? So that means my period is 12. Okay, so once I know what my period is, I can come down and use the calculation. The calculation for the period is 2 pi divided by b, where absolute value of b, where that's the coefficient of my x on the inside of my function. So if I know that that's equal to 12, and I want to solve for that b value, I can go ahead and just cross multiply here. I get 12b is equal to 2 pi, divide by 12. I get my b value to be pi over 6. So that means that the number I put inside here is going to be pi over 6. That's my multiplier. And I'm going to put x. And now I can use my phase shift here. And I have a couple different options for entering this. But I'm going to go ahead and kind of rely on this shifting right here. So with respect to my sine graph here, where did my graph shift? It shifted 1 unit to the right. So how would I represent that inside here? -1. Okay, and so this would be a potential a potential equation that represents this graph. They want you to write the equation in terms of sine. So this one specifically tells you what to write it in. So if I look at my max and my min, what's the total distance from the max to min? 8. And so if I cut that in half, that gives me my amplitude of 4. And if I see the line that it's on, that's going to give me my vertical shift. So just by looking at this right now, I can write my function. They want me to use f of x again. So f of x is equal to, my amplitude is 4. I'm leaving a space because it might be positive, might be negative. I want it in terms of sine. I'm going to keep my phase shift open. And then I am shifting everything up to my midline, which is +2. So this is what I can tell just by making those two measurements calculations. Okay, the next thing I want to do is I want to find my period. Now, because they tell me it's a sine graph, I'm going to use the intersections at the midline. Okay, so if I wanted to, I could use this intersection to this intersection. That gives me one full period of this function. Okay, it doesn't have to be those two, but that's what I'm choosing here. And the reason for that is I can now see I go from 2 to 8. What's that total period? From 2 to 8 is 6. So if I set up my 2 pi over b is equal to 6, and I solve, I get 6b is equal to 2 pi divided by 6. I get pi over 3. So that is my multiplier in front. Notice I put that out in front of everything. That's a common multiplier, but inside my function. And then I'm going to account for my phase shift. My shift here is to the right 2, so I can express that as x minus 2. Now, notice the phase that I used was a positive sign, correct? So I can leave that positive, so this is my function. Okay, so that is one correct answer. Now, I do want to talk through what happens if I use this point instead. If I use that point, then my one complete phase goes from here to here. So my period, if I measure, goes from -1 to 5, which is still a period of 6. So I'm still going to get pi over 3. But this time, the difference is my phase shift on this one. So I still have my 4, still have sine. I still have pi over 3, x minus, and my plus 2. This time my phase shift is to the left 1. So it's a -1. So minus a minus becomes plus 1. But when I look at this phase of my sine graph, is this a positive or a negative? This one got reflected, right? It got vertically reflected. So this one's going to have a negative in front. So these would be probably the two most common forms that you might use to write your equation. Either one is going to be fine. Okay. This one, it shifts it to the left one, but it also reflects the sign. So there's a negative out front. The purple one that I did first shifted it to the right 2, and it kept it the positive sign. Okay. So again, I hope you can see you have those options when you're working through and sketching the graphs of these, or identifying the equations. Okay.
So